Greetings to you, sir. So we are from group 18. And our topic is OFDM and phase lock loop. And OFDM stands for orthogonal frequency division multiplexing. This is my group members, me, Asfa Aiman bin Abdul Jalil, Anas Faruqi bin Ashar, Muhammad Afiq Fakrullah bin Jamari, and we will start our presentation. First, we will be starting with OFDM, introduction. So basically what is OFDM? It's a combination of modulating and multiplexing. As I have said, OFDM stands for orthogonal frequency division multiplexing. It is a method of encoding a digital data on multiple carrier frequencies. And OFDM is a frequency division multiplexing scheme used as a digital multi-carrier modulation method. And a large number of closely spaced orthogonal subcarrier signals are used to carry data on several parallel data streams or channels. So basically it has gained a significant presence in the wireless marketplace, and this also causes a combination of high data capacity with high spectral efficiency in it. It has a high interference as a result of multi-part effect. That means it is ideal for high data transmission used in applications. And the next slide will be how it basically works. So whereby how does OFDM basically works is the sub-channels are closely spaced. So each sub-channels are actually closely spaced. They have no guard bands between them, and they are also overlapped. So there will be more data transmission on it. And how it has no interference while multiple sub-channels overlap. It has no interference because OFDM would combine them closely together in a way they are orthogonal to each other. Because it is orthogonal, that's why it has no interference. And also two or more multiple objects act independently. They work independently. They don't depend on any other sub-channels. So in that case, any neighbor signal would operate with no interference between them. And OFDM would make users of their bandwidth goodly. They make use of their bandwidth properly. Thus, it offers a high data rate transmission between them. And that is why most of the telecommunication industries use OFDM as their basic method. Next will be Asfar.
My name is Asfar Aiman bin Abdul Jalil. I will continue for PLL, or we know as phase lock loop. Okay, for phase lock loop, or known as PLL, is a system that operates on the ability to detect the difference between two signals. The information about the error in phase difference are between two signals to control the frequency. And this system has a lot of application, such as to control the frequency synthesizing on the FM demodulation and data recovery, signal synchronization, and others also like as radio frequency and wireless application. The next one will be for PLL. There should to PLL to initiate, there should be two sine waveform that have same frequency, and we can see that the value phase is different based on the picture, and this PLL will measure the difference angle and between the two waveform, and it will initiate to make the two signal to become have a same signals, have same frequency, same phase. And in the PLL, or known as phase lock loop. In the system, there are three basic elements or three important elements. The first one will be phase comparator or detector. The second one will be voltage control oscillator or VCO. The third one is loop filter. For phase comparator or detector, as the name states, the function is to make the PLL compares between two signals and generate the voltage occurring the phase difference between two signals. And for VCO, the VCO will generate radio frequency signal that we normally consider as the output of the loop, and the frequency can be controlled over the operation frequency band. For the third one is a loop filter. The function of loop filter is to filter the output from the phase comparator in the phase lock loop to remove any component or signal of which the phase is being compared to from the VCO line. The next one will be the impact of OFDM on society environment will continue by Mr. Anas.
So I will explain about the impact of OFDM on society and environment. So next as well. So OFDM in wireless telecommunication. OFDM is an attractive multi-carrier technique for mitigating the effect of the multipath delay spread of a radio channel. OFDM is a well-proven technique in applications such as digital audio broadcasting, DAB, and asymmetric digital subscriber line (ADSL). OFDM is a candidate for the digital video broadcasting (DVB) and high data rate bandwidth efficient wireless networks. Multiple input, multiple output, orthogonal frequency division multiplexing (MIMO OFDM) is the dominant air interface for 4G and 5G broadband wireless communications. It combines multiple input, multiple output (MIMO technology), which multiplies capacity by transmitting different signals over multiple antennas, and orthogonal frequency division multiplexing or FDM, which divide a radio channel into a large number of closely spaced subchannels to provide more reliable communication at high speed. Research conducted during the mid-1990s show that while MIMO can be used with other popular air interfaces such as time division multiple access (TDMA) and code division multiple access (CDMA), the combination of MIMO and OFDM is most practical at higher data rates. MIMO OFDM is the foundation for most advanced wireless local area network (wireless LAN) and mobile broadband network standard because it achieves the greatest spectral efficiency and therefore delivers the highest capacity and data throughout. MIMO OFDM. This form of OFDM uses the concept of MIMO technology. It is being developed by Cisco system. It uses multiple antennas to transmit and receive the signal so that multipath effect can be utilized to enhance the signal reception and improve the transmission speed that can be supported. So the advantage, it can increase subscriber coverage and lower the cost of provisioning and deploying infrastructure, employs both frequency and spatial diversity, creates a robust processing technique for multipath fading and narrow, and lastly, band the interface. So next is
So, hello, I am Afiq from section 11. So, I am going to explain briefly about the impact phase log loop on society environment. So, firstly, is PLL in GPS technology. So, GPS phase log loop linear model, which include the effect of coherent averaging. It was shown that the augmented model allows for accurate calculation of tracking error standard deviation in the presence of additive white Gaussian noise, which is AWGN, and clock phase noise. So, given an accurate input clock phase noise PSD model, the standard deviation of track error was shown to be a useful PLL performance or design metric. Using both PLL simulation and experiment on the tracking error standard deviation shown to be a more reliable and robust indicator of PLL performance. So it is under interference conditions than the widely used phase jitter metric. Secondly is the augmented linear model is shown to be valid until this threshold, which facilitates efficient performance prediction without the need of time-consuming direct PLL simulation. This new performance metric can be used to evaluate the performance of stationary GPS receiver that are vulnerable to wideband radio frequency interface RFI. The method is directly applicable to ground-based reference receivers for differential GPS system, uh, such as the ground-based and space-based augmentation system (GBAS and SBAS), as well as other ground-based receiver that require high continuity of service. It is also relevant to roving receivers if the additional dynamic stresses on the PLL are also taken into consideration. So the next is PLL for environment. So I will explain about PLL in temperature. So the function of PLL is to stabilize the frequency of the signal. This is by using low pass filter PLL so that the frequency keep maintained high. So for the temperature, I have do some research on one article. It says about their circuit use PLL system on low temperature is functioning and keeping the performance over a large temperature, which is range at 300 Kelvin and 77 Kelvin. So the triple path PLL, which can compensate the voltage control oscillator VCO frequency drift over a large temperature variation. And lastly, it is able to continuously operating and reduce the frequency drift by 99% when temperature change from 300 Kelvin down to 77 Kelvin, exhibiting low jitter at low temperature. So that's all from us. Thank you.